All right. So last class, we were doing the integration, right? We had established this notation. And this is what's known as the definite integral. Not to be confused with this, which is called the indefinite integral. All right, so these are the two main ideas from the last few classes that, oh, sorry, take this A and B off. I have no idea why I put that there. Okay, the whole idea here is that if you see this symbol with f of x dx, that this means you need to find the antiderivative of this function and then plus c, and that gives us a whole family of functions, an infinite number of answers, right, because of the plus c. So the answer to this, the answer to an indefinite integral is a family of functions, as opposed to the definite integral where you have these numbers here now, and that means you have to find the antiderivative, plug this number in, subtract, and then you get a number as an answer, right? So this answer right here is going to be a number, whereas this answer right here is a family of functions. Now, when we first started talking about the indefinite integral and we came up with this family of functions, we also talked about a way that we could find a specific function in here. Do you all remember that? I said, okay, if we've got this plus c here, that sometimes we can actually find out what the c is if somebody gives us what we call an initial condition. And then we can find the specific function. But that is very different than this right here. This right here represents the area underneath that curve. Or recall that geometrically? This is the area underneath this curve. So what we're going to talk about today, and this is actually going to be kind of a short lecture because I had an unexpected, I wouldn't say emergency, but something's come up with at my house with a water line that's leaking, and so septic. It's not, but it's part of the water main. So I've got someone coming out to look at it. I would have fixed it myself. It's an easy fix, but it's warranted, so I'm not going to touch it. So, but they're going to be coming out. So I'm going to cut a little short today. So today's new formula, okay, is called the average value of a function. All right, so let me try and explain first of all with pictures what we've got. If we take a function and we look at it from A to B, let's call this function f of x. Then I'll do this in a different color. This right here that right there is the definite integral, right? And that will calculate that area, right? So this is going to give us the area of the blue that you see there, right? So today we're going to talk about something called the average value function, of a function. So imagine if you could that if I go, let's say I pick some value in here, let's say x. I plug that in, gives me a point on the graph. This is f of x. Then the height of this point, how tall that point is the value of the function at that point. Agreed? And I could do that for every point in here. Every point in here, I could find the height. And so the area is basically adding up all the heights through the whole thing. Do y'all get that? So it's like this really represents the sum of all of the heights of the function. Okay? What we're interested in knowing is what is the average value or the average of these heights. Okay, so if I take this height, the next one, all of them, and then say take the average, then it would be like you take your test scores and you take the average. I want to take all these heights and then find the average. And the way to do it is a very simple computation. Here's what it is. The average value of a function on some interval AB is, okay, here's what it is. So that's the area, isn't it? That's this. So it can't quite be just this, because that would be adding them all up, right? Adding all the values up. So when you take a test, like let's say you take 4 tests and you get your 4 test grades, right? You add them up and then you divide by what? 4, right? If you had 10 test grades, you'd add them up and then divide by 10, right? Well here, this gives us the sum of all of the values of the function. This is basically adding up all those values in here. Now I need to divide by however many I have, and that's the tricky part. That's going to be divided by the length, how long this interval is. Okay, so how long is that interval? So like if this was, let's just say this was 2 and this was 5, how long would that interval be? It'd be 3, right? So how did you get 3? You did this one minus this one, right? So what we're going to do to adjust this formula is out in front of it, we're just going to put, I want to divide this by b minus a. So I'm going to put 1 over b minus a out front. Okay, I don't need the parentheses, but I'll put it there. So really, there's only one new thing today for this topic, and that is if we're trying to find the average value of a function on an interval, then what we'll do is we'll find the area, right? And then we will multiply it by 1 over b minus a, which is really the same as dividing by b minus a. Okay? Y'all agree with that? Okay, so that's it. That's it. So let's do a couple of examples. This is still 13.5, yes. So the first example is this. And let me just put that formula back over here just so we have it if we need to reference it. 1 over b minus a times the integral from a to b of f of x dx. Okay, so now, example. Find average value of f of x equals 2x plus 7 on the interval 0, 5. Let's go the interval 1, 5 instead of 0, 5. Now, normally we don't need to draw the picture to do this problem, all right? But I'm going to draw this real quick because that's an easy function to graph. 2x plus 7 is a line, right? This is the line, like y equals mx plus b. It has a y-intercept of 7, and then a slope of 2, which means up 2 over 1, up 2 over 1. So I don't know, maybe it looks something like that. And we want to look between 1 and 5. And try and figure out what the average value is of the function on that interval. So just so you really understand, hopefully you understand what's going on, just tell me, what is f of 1 for this function? 9, right? So if I plug in 1, it spits out 9, right? Plug in 1, it spits out 9. What about if I plug in 5? 17, okay? Now, I could do that for every number in here, right? And what I could do is start listing them all out and then ask you, what's the average value? The problem with that is that there's an infinite number of numbers in here, isn't there? Right? It would be impossible for you to actually go through and like find all of them, plug them all in. But this nice formula will actually do it for us. So to compute this, I first need to figure out what is 1 over b minus a. So for us, that's 1 over, so remember, this is, the first number is always a, the second number is always b, right? So 5 minus 1, that's going to be 4. Okay, integral from where to where? So where are we going to integrate from? 5 to 1 or 1 to 5, just make sure you put the smaller number on the bottom, bigger number on top. And then we're trying to integrate 2x plus 7 dx. Everyone understand that setup? Okay, this is equal to 1/4. So that's this piece. Now, I need to find the antiderivative of that. So, did I say derivative? Yeah. Did I? No, you said antiderivative. Okay, I meant to say antiderivative. I'm not sure what came out of my mouth, but the antiderivative of this function. X squared. So x squared, so we have to take the antiderivative of 2x, which is x squared, and then plus 7x. Right, so I'm using the power rule from the last 4 classes, plus 7x, right? Now I don't do plus c. And the reason I don't do plus c is because we're doing a definite integral, so you don't need the plus c. So that's my antiderivative. And then remember this bar from last time? I said you put this little bar here to help remind you that you still need to plug in 5 and plug in 1 and then subtract. So does that make sense so far? Okay, so let's see what this turns out to be. This is equal to, I'm going to have two things. I'm kind of running out of room here. Which one do I plug in first? The 5. So let's plug 5 in here, see what happens. We get 5 squared, which is 25, right? Plus 7 times 5, 35. So 25 and 35, 60. And then I have 1/4 out in front. Agreed? I'm just going to put 1/4 times 60. Now let's plug in 1. What happens when you plug in 1? 1 plus 7, 8. So 8, and then we still have a 1/4 in front of that. So what is this going to be? What's 60 divided by 4? 15? 15, and then minus 8 divided by 4 is 2, right? So we get 13. Now look at this graph. Remember how we said that when you plugged in 1 you got 9, and when you plugged in 5 you got 17? Does it make sense that the average value of that function should be somewhere in between these two? I mean, if that's your highest point, that's your lowest point, then the average value's got to be somewhere in there. And so this is the average value of that function. So what's useful about this, as we'll see as we move on, is let's say that this is a cost function, right? We have a cost function. And we want to know, okay, we could figure out how much it's costing our company at each point in time. But if we want to say, hey, look, let's look at the cost over this interval. What's our average cost? Then we could just do this formula to get our average cost. Yes, it's higher in some places and lower in some places, but on average, this is what it's costing us. Does that make sense? Okay. Any other questions on that problem? All right. Oops, excuse me. Okay, let's try let's let you try one. How about that? So I'm going to give you a new function. We're going to use some different letters here. We're going to use g of t equals 4t minus 3t squared on the interval -2 to +2. So why don't you work on that? I'll let you work together on that, or alone if you're one of those people who like to work alone. Same exact process as the last problem, right? Okay. Go ahead, raise your hand if you have any questions as you're going through, and I'm actually going to graph the function just so we have it over here, okay? Just be careful on that b minus a. B minus a is not 0.
Oh.
2 minus -2. Right? 2 minus -2. B is 2 minus, the formula, look at the formula, b minus a. Okay,
So
what's a though?
The +2.
That's b.
A and B, right?
Yep, okay, so you wrote down 2, and then minus, and now, no, not 2, what's a?
-2.
Negative, so it's minus -2.
Minus negative.
See? See what I'm saying? Because the formula has minus in it.
Oh.
So you're going to be subtracting a negative. Does anybody need a hand? Are y'all doing okay? Need a hand? Okay, I'm gonna come over there. I'll be there in just a second. Let me draw this for y'all. What you got?
I got everything. I couldn't find the power rule in my notes.
Okay, this is our power rule. Antiderivative of x to the n is 1 over n plus 1, x to the n plus 1. Yes, and that 3 and the 1/3 are going to kill each other off, so you just get t cubed. And you can always just do a quick check, like what's the derivative of t cubed? 3t squared, right?
Yeah.
So you can just check, yes, that is the
First
correct.
one's go to, right?
What was it?
Just n plus 1.
N plus 1, but n there is 1, isn't it? Like 4t is really t to the first power, right? So when you do the antiderivative of this, the 4 comes down, and then your n is 1, right? So you got 1 over 1 plus 1, that's 1/2 t squared. Okay, look like you've got it set up right here. You just need to be able to find the antiderivatives of both of those. So t cubed, you're okay with that? You know how you got that?
Oh, as well.
Yeah, you're using, hold on. Yeah, you're using this formula that we talked about the other day. Here we go. There, right there. Okay? So look at this. You've got 3t squared, right?
Right.
All right. Since the 3 is attached to this with multiplication, just bring it down and totally ignore that, okay? So that's not in our eyesight here. We're just looking at that. Okay, so n here is 2. Okay, the formula says it'll be 1 over n plus 1. So 1 over what plus 1 for us here? 2 plus 1. X to the
2 plus 1.
2 plus 1. Okay, good. So now, this is really 1/3. Right here, 1 over 3. Like that. And then this is just x to the 3rd. And these 3's cancel. Oh, yeah, I'm using t, sorry. T. So those cancel, you just get t cubed. Okay, that's where that comes from. Now, you need to do the same thing on 4t. 4t, just ignore the 4. This is t to the first power, right? So see if you can do that one. Okay? You guys okay?
A little bit.
I think.
Let me see what your
So
2t squared minus t to the 3rd. Yep.
And then, so from there we practically
Yep.
do plug in those
2,
numbers.
2 first, right?
Yeah.
Yeah, so you'll go 1/4. And then you got to do what's in that parentheses. Yeah. Just look how I have the 1/4. I have it on the outside. See how you have see how you have 1/4 and then this is in parentheses? Yeah, there you go.
Is that the answer?
I don't know yet.
Oh, okay.
Let me see here. So when you plugged in 2, did you do the 1/4 after?
I did it all together.
See, this right here has to be done first. So if you plug in 2 there, you get 8 minus 9 is -1. Yeah, that's going to be off a little bit. I'm going to start writing this up on the board. Forgot my parentheses here. Let's see, 4, 8. 8 minus 8. Okay. 4, 8. This time plus 8. 16. -4, it looks like. Okay. All right, so -4 appears to be the answer for this. Yeah, we'll do another one. So going from here to here, like we are seriously like on the 3rd day of this, 3rd class. So we've had at least a week and a half to get to the point where we're comfortable with this. So if you're still struggling with that, you just need to go back to that homework assignment from 13, was it 13.1 or 2? Yeah, it was 13.1. If you're still having trouble with this, go back to the homework from 13.1. Just keep doing that homework assignment over and over until you get it down. Then I think the next tricky part of this problem is this parentheses and the 1/4. You have to be real careful that you compute what's in here first before you hit it with the 1/4. So when you plug the 2 in, you have to do all that, figure out what all this is, and then hit it with the 1/4 at the end. So do you all see this? Are there any questions over any of them? How's it what? Any questions on any of this? We're good? -2, -2 cubed. -2 times -2 times -2 is -8. But then you're subtracting it. That's where the +8 comes from. 16 divided by 4 is 4, but you're subtracting it, -4.
And the first one is 0.
The first one is 0. Yeah, sorry, I should have just, this right here is 0 times a fourth, and that's just 0. Now, I went ahead and put the graph over here so you could see it. B. So if we're looking at this, see, we're not calculating this area, right? I mean, that right there is calculating the area. But then this is like helping us take the average. So does it make sense that our answer is negative? Yeah, because if we're if we're plugging in, what we're saying is if we start plugging in values of t here, that we're going to get certain measurements of heights of the function, which are going to be negative values because they're below the x-axis, or yeah. And then we try and figure out, well, what's the average of those negative heights? The average would be -4. All right, let's do another one. Okay. Do you prefer to do it on your own and then we go through it? Yeah? Okay, let's do another one. Okay, how about find the average value of, let's go back to f of x. F of x is the cube root of x on the interval 1 to 8. Do y'all know what the cube root of x really means? X raised to the 1/3. So you're going to have to mess with some fractions here. If you don't want to see the answer, just don't look up here. that's just 2 to the 416. Yeah, I think last time we had all talked about wanting to use decimals, didn't we? You all said that you all liked decimals. So what I'm going to do is, I think at this point right here, I'm going to break off and do it. The problem if we had done decimals. So let's see. Okay.
We have these equation one.
Do what? Gonna run out of room here. Let me do it this way. Eight. Let's see if I did this wrong. 8 to the 1.33. 50.89 minus. Did I? Yeah. I'm getting 1.59. I'm not sure about this. Okay, so do y'all want to talk about this yet? No?
We're supposed to use, we're supposed to use the equation, n1 plus n1 thing, right?
1 over n plus 1, x to the n plus 1.
What if we just did it, because what I did was that I just went straight to finding out what could equal 1 on that equation for finding the antiderivative. Like, I didn't do that part, I just did right below your arm. That part, yeah.
You didn't do what part?
I didn't do the part above, I just did straight down to that,
So you got this?
without
You,
doing that.
how did you do it?
Well, I saw like how I saw like if you do 1/3 plus 1, that makes it 4/3, right? So I said bring it down, so just not like, oh, just flip it over so you can get something.
That's fine. That's fine. As long as that's what you're doing up here. You're adding 1 to 1/3, which is 4/3, and then you're doing 1 over 4/3, which flips to become 3/4. And then this is 1 plus 1/3, which is 4/3. So what I've done here in the black is me not using a calculator. Just using fractions and flipping and multiplying these fractions and plugging in. And I did use my calculator for this, although you don't need it. And then I got this as a fractional answer. And then if you use decimals, which I said, we talked about y'all wanted to use calculator, right? Which is fine. If you use decimals, then you have to do 1/7 times this, you should get that. And then 4/3, you have to round it, it's 1.33. Then you plug in, you should get 1.59. These two numbers are really close. They're not the same though. I mean, this is the exact precise answer. There's rounding error in this problem. Yes?
I was going to ask if what if it's 1.60?
What is it, what?
What if it's 1.60?
1.6 what?
1.60.
1.60.
1.59.
Yeah, it's actually, it's not 1.60 exactly. It's 1.607 something, and it keeps on going. So it's approximately 1.6, okay? Approximately. And the previous problem was nice. We got a nice answer. -4, done. But when you start adding these fractions into it, you can see how it can become a little bit problematic, right? Are there any questions on any of the work? You sure? Okay. All right, so let's try and do a word problem now. Which one shall we do? All right, let's do this one. Let's say we have a cost function which is 20,000 plus 10x, and this is the cost of printing X dictionaries. Part A, find average cost of printing 500 dictionaries. Part B, find average value of cost function on the interval 0 to 500. And then part C, what is difference between part A and B? All right, so this company makes dictionaries, all right? So when they have to set up their equipment and everything, this is the cost function that they use. So it takes them this is what we call a fixed cost. It's going to cost them, and this is in dollars, okay? So it's going to cost them $20,000 to set up the equipment, get everything ready, and then $10 per dictionary that they print, right? That's what that's saying. So first question is, find the average cost of printing exactly 500 dictionaries. So how do we do that? What is part A asking us for? Plug it in? What do you mean plug it in? Okay, so if I take, for part A, if you plug in 500 into this, what is that going to give you? In words, what is that giving you? If you just take 500 and plug it in here, what is that going to give you? The cost of what? Of printing exactly 500 dictionaries, right? That's not what it's asking for, though. It says find the average cost of printing 500 dictionaries. So think of it this way: if you plug 500 in there, right? That gives you the total cost of printing exactly 500 dictionaries. The average cost is the cost per dictionary. Per dictionary. So what we need to use is the average cost function. So do you recall seeing that function earlier in this class and in 1324? No? The capital C with the bar on top of it is the average cost function. All right? And all it is the cost function divided by x. That's all it is. So don't let that notation scare you. It's just that function over there divided by x. All right? So, what's that? I'm not sure what you...
It's a 20,000 plus 10 times 5,000 500. I did, my bad.
Okay, so the average cost of doing 500 dictionaries, right, should be the cost of doing 500 dictionaries divided by 500, right? And that's going to give you the cost per dictionary for making if you make or produce 500 dictionaries. So plugging in 500 is slightly correct. You still need to divide by 500. So what does it turn out to be? 50? Okay, so I'm going to trust that answer, $50. $50 per dictionary. If you manufacture 500 dictionaries, your cost is $50 per dictionary. Yikes. Something tells me, I used a different number here, so our answers don't match. Okay, that better be a really nice dictionary, huh? Leather bound, one that you pass down through the family. Who uses dictionaries anymore? Yeah. My daughter in her school right now is learning how to use an encyclopedia to look things up. I'm like, encyclopedia? I haven't seen a set of encyclopedias in a long time. All right, so if we produce 500 dictionaries, the average costs $50 per dictionary. Now, what is Part B asking us for? The average value of our cost on the entire interval 0 to 500. That means if we make no dictionaries, or we make 500 dictionaries, or we make anything between, right? For each value of dictionaries, right? 0, 1, 2, whatever, we're going to have a cost for each one. What's the average value? Right? The average. So Part B is asking us for 1 over 500 minus 0, which is 500, integral from 0 to 500 of,
Do you want the derivative first?
just the function itself, right? 20,000 plus 10x dx. So that's what we're doing for Part B. So let's go ahead and do that. I'm going to do that right here. So for Part B continued here, this is 1 over 500. The antiderivative of 20,000 is what? 20,000x. And then 5x squared. Good. And we want to evaluate that at 500, and then we want to plug in 0 and subtract. Understand? So give myself sets of parentheses here. Let's see, 1 over 500. And then, ugh. I just don't feel like plugging these in, but that's why I have a calculator. 20,000 times 500. So I did 20,000 times 500 plus 5 times 500 squared. So make sure that you can get that. Is that millions? 11,250,000? 11,250,000 is what I get when I plug in 500. And then minus 0, because when I plug 0 into this, everything goes away, right? 0, 0, 0 plus 0, 0, and then 1 over 500 times 0, 0. So this whole back end is 0. So divide by 500 now. 22,500. This doesn't make sense. Hold on. The average, something is off. Hold on. 20,000. No. You know what? This is right. This is right. So look, let me try and convince you.
That we're paying $22,500 for dictionaries? That's the same.
On average.
On average.
On average. Okay, but watch, let's take a look at something. Here's our cost function, right? I know it seems absolutely ludicrous right now that this is our average value, but let's take a look at what this looks like. This is a line, right? This is a line, has a y-intercept of 20,000. Okay, so there's something critical that we haven't done yet, which is going to make this make more sense, okay? So it has a slope of 10, which means the slope is positive. Agreed? Okay, so I have a positive slope. So this is my cost function. If I graph it, it's a line. It keeps going forever. Now, if I go to 500, right, like that, what this gave me, think about the values here. Like if I plug in 0, what do I get? 20,000, right? Agreed? If I plug in 500, I get a number bigger than that, yes? So when it's saying what's the average value of the cost function, the average value of the cost function on this interval should be something between 20,000 and whatever this is. So does it make sense that our average cost would be 22,000? Yes? So now what you would, if you wanted, the big difference is between part A and part B is this. Part A, we are finding the cost of producing, the average cost of producing a dictionary, which was $50, if we produced exactly 500 dictionaries. This is giving us the average value of our cost function, okay, which is looking over an entire interval instead of one particular point, right? Instead of one particular point. So what if I were to say, okay, I'm only going to produce 100. Let's say I'm only going to produce 100. Then how much is it going to cost me per dictionary using the average value of the function? I would just take this and divide by 100, right? And that would give me an approximation for the exact cost, which was still pretty huge, right? What would that be? $225. That's a very, very expensive dictionary. So I don't want to be producing a lower number here because my average cost is going to be high. But the further out I go, the more dictionaries that I produce, the lower that cost should be. So I'm trying to think of, I feel like I've not clarified why these two numbers are so different. The part A, what we did was we went exactly to 500. We went up to this value, right? We figured out how tall that was, and that gave us a cost. But then we divided it by 500, and that gave us a cost per exactly one dictionary. This value is not looking at one particular cost or one particular number of dictionaries. It's looking at an entire line interval from 0 to 500 and saying, on average here, what's it going to cost? Okay? So we can't divide through by anything. See how we took this and then we divided it by 500, didn't we? Because we knew there were exactly 500. But when you're looking on an entire interval, you can't divide it by anything because you don't know how many you've made. It's between 0 and 500. So it's giving you an average cost. So my company knows that if I produce between 0 and 500 dictionaries, right, my company knows it's going to cost me on average, us on average, about this much money to do that. So, of course, the more we sell, the more we actually sell, the lower per dictionary cost it's going to be. All right, I hope that that makes some sense. If you're confused, then the assignment's already listed. What time is it? Oh, wow. Okay, well, I've gone past where I said I wanted to go, but the assignment is the same one that's it's in your schedule. We're talking about average value, page 766, number 49A. It's all listed there, 51A, 55A, 77, 81, and 91. But the title of the section is, it's 13.5, but it's 13.5 on the schedule is broken into two categories. We already did the fundamental theorem of calculus last time, and now we're doing average value. Okay? So it's been requested that I provide a review for the next exam, which the next exam is on Wednesday of next week, I believe. Yes. Okay, so that way I guess you can do that on Thanksgiving. I'm sure that's all you want to do. On the weekend, I'm kidding. Okay, so my intention is to do that. I'll probably send it out as an email sometime on Wednesday. Now, Wednesday, I'm required to have class, all right? Like, I get in trouble if I cancel class. But I also understand that, people travel. It's the day before Thanksgiving. In my history of teaching, Wednesday has always been a very, very small, intimate group of people that are all here, and like half, more than half the class is gone. So I will be here. I'm recording the lecture. I won't penalize you for not being here, but just understand you're responsible for what you miss, all right? So that means you go back and watch the video. I'll post it on YouTube. But if you're not here, I get it, all right? Now, if nobody shows up,
I'm showing up.
okay, there we go. So never mind. Yeah, I'm just saying, if nobody were to show up, I'm just letting you know I'm not going to make a video. Like, I'm not going to stand in here and be like, "Hello, nobody," So, so I'm not telling you not to come. Please don't get me wrong. But I also understand.
Nobody shows up then, right?
What's that?
So it'll be better if nobody shows up.
I'm going to be here, no matter what.
But there'll be no less that.
Yeah. It would be. Yeah. So if no one showed up, then that material can't be on the test.
Oh, wait a minute, what?
No, I can't say that. Okay, sorry, I got to cut out. I got to meet this person, but I do have time if you still want to talk about that.